Okay, let's take a look at an example sentence. So Sam saw a movie, the same one we did before for our syntactic structure, but let's see how the meanings look. I'm going to zoom in, I'm going to use colors when I can, and we'll go through it piece by piece. And there are examples on Canvas for you to try in PDFs and on your homework as well. So the structure Sam saw a movie, we have to take a movie, so this NP at the bottom, we move it up into a new node, and we're left with a trace. So we'll start with identifying the meaning of the trace. So we have T1. So the meaning of T1 is going to be the assignment function g on T1. And this will carry up into the tree, and this is going to be our direct object. So we don't know what it references yet, but it's a placeholder for whatever we're referencing. It's a placeholder for that object. Saw is going to be the same thing as we've done before. So saw is a transitive verb. It looks for pairs xy such that x saw y and m. This goes up the tree, and our rule for our transitive verbs happen. So we're looking for the set of x now, such that x and np is in the transitive verb. So we have our subject and our direct object. We know what our direct object is. Specifically, it's g of t1. So our result here is now we're looking for the set of x such that x saw g of t1 and m. Now we don't evaluate what g of t1 is until the very end of the derivation. So we just leave it as gt of 1 till the very end. Why? Because if it's bound, we're going to replace it with that bound variable. If it's free, then at the very end of the derivation, we check our assignment function chart to see what t1 points to, and it gets the free meaning. Okay, we have a proper named Sam, so Sam just goes up to the tree as Sam prime. And as we go to S1, well, this is going to be true if the NP is an element of the VP. So if Sam prime is an element of the set of X, such that X saw G of T1 and M. So now we have to introduce the part where we have a movie, since Sam saw a movie. We know that Sam saw G of T1, which, by the way, in the predicate logic translation, we have at this point is saw Sam X. We don't know what X is. That corresponds to G of T1. But we're about to introduce the part where we have movie X, it's bound, and then movie corresponds with X. So we're about to introduce that part. Okay, so going to the left side, it's not that far left. We don't give meanings to the determiner, or the noun phrase 1, although the NP1 is indexed for reasons for binding, but we do give meanings to movies and the common noun. If you're wondering still why we don't do this, set theoretic truth conditional semantics just doesn't have a nice way of doing this. With functional truth conditional semantics, which is something you do in a graduate semantics course, it becomes a little bit more possible to do it. So that's why we do the units. But anyway, so movie, the set of X is that X is a movie. The common noun gets the same meaning, so the set of X is that X is a movie. And now we go to our rules. Okay. So I've just repeated the rule here from before. So, and I'm not referring to anything in particular yet. That's in the second line, but in the first line, this is just the rule. So we have some movie, or specifically a movie. So this is the existential rule. So we say it's true if for some D in our universe, so if there's something in our universe, D is in our noun, so D in this case is a movie, and the remainder of the sentence, so Sam saw G of T1 and M, that is true where T1 now points to D. So we're basically saying there's some individual D in our universe where D is a movie and Sam saw D. So if I remove some of this here, and we talk about the actual translation. So this is 1 if for some D in our universe, D is in the set of X's that X is a movie in M. So D is a movie. This is like saying there exists an X such that movie X, and Sam prime is in the set of X's that X saw D in M. Now notice how these two differ. These refer to the same thing, but in our assignment function, when we went G where D replaces T1, we've made this change because we've bound this variable. So G of T1 now realizes itself as D, and that's because in our predicate logic translation, exists an X such that movie X and saw Sam X, we want these to be co-indexed. We want to know that the thing that Sam saw X is the movie. And what's the movie? Well, D is the movie. We're saying if for some D in our universe, D is the movie. And we want Sam to see D, which is that movie. So that's what our assignment function is doing there. And that's why we see these differences in our tree. But this is just watching the rules apply to the tree. And at the end of the day, again, the trees themselves, the meanings of these sentences correspond exactly to the meanings of the predicate logic translations. So if there exists an X such that X is a movie and Sam saw X, we're saying there is some D in our universe where D is a movie and Sam saw D. And we're just taking that translation and putting it in terms of sets. And you can do that either by following the rules or by thinking about this visually. So, for instance, and think of this visually too. Here's our universe. We're trying to find a particular movie D. So this is a movie, and also it happened to be that Sam saw this particular movie. So that could be, one way of looking at it. So you could have a set full of things that are movies, and maybe these are sets of movies that Sam saw, and this D just happens to be in both of those sets. Anyways, this is a quick video just with one quantifier. We'll do the next video with two quantifiers, and we'll show how the process is exactly the same, but we'll use some colors to differentiate the variables so we can see how these variables change depending on how scope ambiguity works. As always, if you have any questions, post on the discussion board or email me.